type 3 properties or of inverse functions, trigonometric, inverse trigonometric functions. Now third property, type of third type of property. These properties are of, if we take first A, if I take sine inverse of minus x, that is equal to minus sine inverse x. Because we have to take here inverse function. If it is sine inverse of minus x, then it is minus sine inverse x. Here also x belongs to minus 1 and plus 1. And x is here minus 1 and plus 1. Same that this is the A part. Now cos inverse of minus x is equal to cos inverse x. No change here. Here also x belongs to minus 1 and plus 1. Okay, that is can be the values. Let me take this square bracket. C part here. Tan inverse of minus x is equal to minus tan inverse x. As we talked about that cos x is an even function. Cos inverse x is also even function, but it's positive. In case of this is here. Okay, so that is tan inverse x. Here x belongs to, okay, this is real numbers, real set of real numbers. X belongs to set of real numbers. In case of this D part here, let me take cosec inverse of minus x equal to minus cosec inverse x. Here x belongs to r minus 1 and plus 1. In value accept the values. E part here, secant inverse of minus x is equal to positive sec inverse x. So sec inverse x and cos inverse x both are even functions, so they are always positive. Okay, so this is the value here. And here x belongs to again r minus 1 and plus 1. Okay, then cot inverse x, cot inverse of minus x equal to minus cot inverse x. Here also x belongs to set of real numbers, just type of 10. Okay, so these are the third type of properties we have taken. Now fourth type of property I'll take, but before that let me take. Okay, but in case of cot inverse x, it is pi minus cot inverse x, and in case of secant inverse x, also pi minus this one. These two are exceptions here. Here in case of secant inverse x, it is pi minus, we will just prove this, pi minus secant inverse x. In case of cot inverse x also, it is pi minus cot inverse x. In case of secant inverse minus x, okay, this we defined that this is how pi minus secant inverse x is there, the values. If it is negative value, secant inverse of minus x, this is equal to pi minus secant inverse x. And cot inverse, in case of cot inverse minus x, is also pi minus cot inverse x. Okay, so this is the type 3 properties. Now type 4 properties, let me take. Okay, so this is type 4, type 3 properties we have defined. The properties of inverse trigonometric functions we are writing here. Okay, all these properties of type 4 properties of type 4 let me take, or fourth type of properties. Now if I take, I have taken these tan inverse x plus cot inverse x equal to pi by 2. All these properties in 6th question I have talked about, but let me take those type 4 properties. Okay, type 4 properties, let me take, what is that? Cosec inverse x, if I take, or sine inverse x, let me take. Sine inverse x equal to cosec inverse 1 upon x. Okay, similarly, cosec inverse x, this is, let me take A, this is B here. Cosec inverse x equal to sine inverse of 1 upon x. Then C, let me take cos inverse x. Cos inverse x equal to second inverse 1 upon x. Similarly, second inverse x equal to cos inverse 1 upon x. This property we will talk about. This is D part we are taking. Then E, tan inverse x equal to cot inverse 1 upon x. We will talk about. And last sixth one is cot inverse x equal to tan inverse 1 upon x. Okay, so this is how we have to talk about. In the fourth type of property, these six properties are again based on trigonometric functions. All these questions we will talk about it, how this is. They are still I'm writing the properties. Okay, this is type 4 properties. We have taken 4 type of properties. Let me take next 5th type of properties. All these properties are you can find in number of books here. I've taken all these queries from the student side, so I've divided them into categories. I've taken all of them in a same type of properties, in categories. This is how. This is type 4 property. Let me take now type 5 properties. Property number 5th or 5th type of property. Okay, that is here. So properties of type 5. What are those? In this case, let me take that these properties are okay. Type 4, I can take here. This is first. Let me take sine inverse x plus cos inverse x equal to pi by 2. This is here we will prove that how this sine inverse x plus cos inverse x pi by 2. Where minus 1 is less or equal to x, or x belongs to minus 1 and plus 1. This is first property of type 5. We have taken B. Then second inverse x plus cosec inverse x is also pi by 2. Here x belongs to, I have taken here. Okay, here x is less or equal to minus 1 or greater or equal to 1. Okay, so it means x is greater or equal to minus 1. X is less than, x is less or equal to minus 1, or x is greater or equal to 1. It means less than minus 1 but greater than plus 1 or equal to 1. The values of here x are here. This is the C property here we have taken. Here we have taken as C property. This is also pi by 2. Okay, then C, let me take tan inverse x plus cot inverse x. Same angles are there. It is xx. This is also pi by 2. Pi by 2. This is also equal to pi by 2. And here x belongs to set of real numbers. X belongs to R here. This is the property number B we have taken there in the question number 6. That I will prove, but before that I will note it down to the 5th type of properties. Now 6th type of properties are there. Okay, only these type 4 type of properties are there. Okay. These are the 5 types of properties of trigonometric function. I'll take them one by one, but first let me take these questions, and then all these functions are defined here. Questions are taken based on them that I'll define here. Okay, so that's why I'm not taking them one by one, because that may take more time. But these questions are here. This is question number 4 I have taken. Now let us take what is the question number 5. These properties I have taken here. Now let us take question number 5. Now question number 5 says that how to express one inverse trigonometric function in terms of another trigonometric function. Another inverse trigonometric function. This is question number 5. How to express one inverse trigonometric function. One inverse trigonometric function in terms of another. This is question number 5 here. How to find the value of one inverse function in terms of another inverse function. This is question number 5. All these 5 questions are very important to understand the basics of inverse trigonometric functions or inverse circular functions. Yeah, circular functions or trigonometric functions, same thing. Okay, because circular functions, why? Because when trigonometric functions are expressed in terms of a circle pi by 2 radians, in terms of radians, pi and multiples of pi or some multiples of pi. So that is how circular measurement of angles we have defined. Okay, so that is circular sexagesimal, but this is circular functions here. So we are taking circular functions because they are expressed mostly in terms of pi, in terms of angles. Okay, so that is circular function in case of angles of a circle. This is 2 pi. Okay, that is the question number 5. So how to find value of one inverse function in terms of another. So let me take that. First, let us take. Let me express one. This is solution or proof. Let me take solution here. Solution or proof. Okay. If I take sine inverse x equal to, let me take sine inverse x or sine inverse theta equal to x. So let me take sine inverse x equal to theta. That is sine theta equal to x. We have sine theta equal to x. Okay, this is the first thing. Now, if in terms of x, if I take, sine theta, if I find cos theta, what is cos theta then? Cos theta equal to under root of 1 minus sine square theta. If you know what, that means this is 1 minus x square, because sine theta is x we have taken. So cos theta is expressed in terms of this. So cos inverse x, theta here is equal to, this implies that theta is equal to theta is sine inverse x. Here theta is equal to cos inverse under root 1 minus x square. And theta is sine inverse x. So sine inverse x is expressed in terms of cos inverse x and the trigonometric function 1 minus cos square. Okay. This is cos inverse of under root 1 minus x square. This is how sine inverse x equal to. Similarly, if I define sine inverse in terms of tan theta in terms of this, what is tan theta? Since tan theta is equal to, so taking here sine theta equal to x, tan theta is sine theta upon cos theta. That means, what is that? Sine theta is x here, cos theta we have taken under root 1 minus x here. This is cos theta equal to under root 1 minus x square. This adds up. It means theta equal to tan inverse equal to, or theta is equal to tan inverse of x upon under root 1 minus x square. This is here. That means tan inverse theta is same cos inverse x. Cos inverse x equal to this. Let me take all these values. And this is one type of thing I am talking about. Cosec. We know about cosec inverse x. Okay, or cosec theta. Now then cosec inverse x, if I find out, because cosec theta is equal to, if you take 1 upon sine theta, that is 1 upon x here. So theta is equal to cosec inverse 1 upon x. Okay, so this is sine inverse x equal to, in this way we can express what is cot inverse x. And cot inverse x, if I take cot inverse x equal to, we have taken here cosec theta equal to, so cot theta equal to cos theta upon sin theta, and cot theta equal to cos theta upon sin theta. that means under root 1 minus x square upon x. That means cot inverse x equal to, here this is cot inverse under root 1 minus x square upon x. This is sin inverse x equal to cos inverse and root this equal to cot inverse and root 1 minus x equal to tan inverse this value, that is right here, is equal to tan inverse x upon under root 1 minus x square equal to cosec inverse 1 upon x. Or if I take sec inverse, then what is that? Equal to secant inverse. What secant inverse x is 1 upon cos inverse, and sec theta equal to 1 upon cos theta. Okay, and cos theta 1 upon under root 1 minus x square. This is 1 upon under root 1 minus x square. Okay, this is how secant theta this is. This secant theta here. The secant theta is 1 upon cos theta. Cos theta is under root 1 minus x square. This is cos theta equal to root 1 minus x square. All these sines, all the 6 sine, cos, cot, tan, cosec, sec. This is how we can express them in terms of one function, in terms of another function. This is question number 6. This is the process of how we can solve it. Okay. Again, if I take sine 2 theta, tan 2 theta in terms of tan theta, cos theta. Okay, in other terms also we can express that in terms of tan theta also. So this is how we can express one trigonometric function or this inverse trigonometric function in terms of another trigonometric function. Okay, this is one example here we are taking. Okay, so this is question number 5. We are completed. Let us take now question number 6. Okay, now question number 6. The questions which we have taken here, and just proof of all these properties we discussed about. This is proof of that. We can take that one by one. Question number 6 we are talking about. Part A, prove that. We prove here. Okay, sorry. To prove here, what we have to prove? First is A part. This is sin inverse x plus cos inverse x equal to pi by. Here, x is lying between minus 1 and plus 1. X belongs to what? X is greater than minus 1 and less than or equal to plus 1. X lying between minus 1 and plus 1. That way we can write if what is there. And let us take okay, sin inverse x equal to, let me take theta. That sin inverse x equal to theta. That means x equal to sin theta. That means x equal to sin theta here. Okay, sin theta. X equal to sin theta. Yeah. So if I just express this x equal to sin theta here. Okay, now we know that what is sin theta? Theta lying between, sin theta is lying between 0 to pi or minus pi by 2 plus pi by 2. This is minus pi by 2 plus pi by 2. Sin theta or x lying between, sin theta is lying between minus 1 and plus 1 that we have given there. Okay, now let me take sin theta equal to, okay, cos of pi by 2 minus theta. This we know what? We can write it as sin theta equal to this. But here sin theta is x here, x equal to cos of pi by 2 minus theta. Okay, or this is cos inverse x here. So cos inverse x equal to pi by 2 minus theta. We can take this minus theta to this side. This is theta plus cos inverse x equal to pi by 2. Theta is, we are taking here sin inverse x. This is sin inverse x plus cos inverse x equal to pi by 2. This is one of the methods we can do. Now, how these values are lying between 0 to pi by 2. Okay, or I mean these two angles are lying between 0 to pi by 2. So if I take that sin theta here, this x or theta is lying between minus pi by 2 plus pi by 2. Here theta is lying between minus pi by 2 to pi by 2. The theta is okay, and this pi by 2 minus theta. If I take sin theta, and this pi by 2 cos theta is, cos theta lies between 0 to pi. This cos pi by 2 minus theta, because sin theta is equal to cos pi by 2 minus theta. This is okay, this has been proved here. This property we have proved, but for the basics of this, I mean angles, if we have to take the ratio of those angles, like sin inverse x plus cos inverse x is equal to pi by 2. So this we have just proved that sin theta equal to, we know that cos pi by 2 minus theta. But this pi by 2 minus theta, how this has been obtained? Let me just talk about that. Here, theta lying between minus pi by 2 plus pi by 2. Now if I take cos inverse x equal to also theta, in this case theta lying between 0 to pi by 0 to pi, 0 is less or equal to theta, with theta here, but theta must be in angle phi, okay, less than pi. Okay, so if I take these two here, is minus pi by 2 is less or equal to 2, or for the theta here, or we take here phi, then theta plus phi we could take. Okay, so if I take this as phi, let me take phi, this is phi here. So sum of these two will give us minus pi by 2 plus theta plus phi. Okay, theta plus phi is less or equal to 3 pi by 2. So minus pi by 2, this is pi by 2 plus phi, this is 3 pi by 2. Theta plus phi is lying between minus pi by 2 plus pi by 2. Now if I just subtract pi from both sides, pi from both sides, it will be pi. If I subtract from here, adds, let me take adding pi here, that will give us, or if I subtract pi, this is equal to pi. Okay, this is minus pi by 2 plus pi. Okay, let me take less or equal to theta plus phi plus pi, and this less or equal to 3 pi by 2 plus pi is equal to 5 pi by 2 here. 2 pi plus 3 pi is 5 pi by 2. But in this case, if I have to limit them between 0 to pi by 2, theta plus phi. Now in this case, because this is lying in between, 5 pi by 2 is more than, 3 pi by 2 is more than 2 pi, so we have to take only, because these two are positive between first quadrant, and cos is positive in first and fourth quadrant, right, and sin is positive in first and second quadrant. So in this case, in this situation, I mean, but we just take that theta plus phi, if I take, is greater than minus pi by 2, is less than, or here I have to take, first time taking is pi by 2 less or equal to theta is equal to pi. This is the second quadrant in which sin is positive. Okay, second quadrant, and cos is positive in the first and fourth quadrant. So if it is 2 pi minus this, in that situation, we can take theta plus phi, take that side is 0 is less or equal to theta plus phi is less than pi by 2. Okay, so these two are lying in the first quadrant in this case. First quadrant all are positive. Because of that, we have taken this pi by 2. Therefore, theta plus pi by 2, these two values if I substitute, theta is sin inverse x plus phi is cos inverse x is less than or is equal to, you can take is less or equal to phi by 2. This is second method we can do. We have take the values in which both are positive. Both are positive only in the first quadrant, 0 to pi by 2. This is the interval in which both are positive, sine and cos. Because of that, we have taken this pi by 2. Theta plus phi, the sine inverse x plus cos inverse x equal to pi by 2. This is the first A part. Okay, or we can take that sine inverse and cos inverse x that we can define. Okay, so now second part. This second part here. The B part is this. Now B part is tan inverse x plus cot inverse x. That is tan inverse x plus cot inverse x is also equal to pi by 2, where x belongs to set of real numbers. Here x belongs to set of real numbers. Okay. Now in this case, let us take if tan inverse x equal to theta, we have taken for x equal to tan theta. We take this tan inverse to that side, x will be equal to tan theta. This implies that. This implies that. The x equal to tan theta. Or we can write tan theta is equal to, this is x equal to, we are taking x equal to tan theta. Tan theta can be written as cot pi by 2 minus theta, because tan 90 minus theta, sorry, cot 90 minus theta is equal to tan theta. This is there. So it means this x equal to cot pi by 2 minus theta. Also we can write this implies that x equal to cot inverse, sorry, cot of pi by 2 minus theta. That means cot inverse x equal to pi by 2 minus theta. So this minus theta taken to this side. Theta plus cot inverse x equal to pi by 2. This we know about. Theta is here tan inverse x. So therefore this implies that tan inverse x plus cot inverse x is equal to pi by 2. So what we have to know that in the first quadrant, if we have proved in the beginning that when, in the first quadrant, cot inverse x plus this one, in the first quadrant all are positive. So all are positive in this case. Pi by 2 minus theta equal to tan cot tan, sec cosec cosec sec, sin cos sin. In this way we discussed about taking the right angle triangle in first quadrant, in second quadrant, third quadrant. In that situation we discussed about this in the beginning. In the same way, this is the second one of the methods here. If we take first define the interval here, and that interval will give us this 0 to pi by 2, because both are positive either in the first quadrant or in the third quadrant. So in the third quadrant, the value phi is less or equal to, let me take tan theta, with tan theta of tan inverse x, let me take. If I take phi is less than tan theta is less than pi by 2 or 3 pi by 2, sorry. This is third quadrant in which both are positive, tan and cot. Similarly, cot is also positive here in the same. Or if I take first quadrant, then 0 is less than cot theta is less or equal to pi by 2. Okay, so in this way, if I just add them, this is pi by 2. This first quadrant, if I take, this is 0 to pi by 2, 0 to pi by 2. When 0 both are added up, then if I take this 0 to pi in the first quadrant, because both are positive only in the first quadrant, this is 0 to pi by 2. That means both are added up, that will be tan theta is less plus cot theta is less than pi. So pi by 2 plus pi by 2 is pi. So 0 to pi, the sum of these two are lying between 0 to pi. Okay, 0 to pi means in this it is negative. We will take that as negative, but if I divide it by 2, okay, so that means, or if I subtract minus pi by 2, Here also minus pi by 2. This is tan theta plus cos theta minus pi by 2. Okay, is less or equal to, is less or equal to, is less than minus pi by 2 means pi by 2. Okay, so this pi by 2 take to this side. It means cos theta per tan theta is, if both are equal, in place of tan theta, if I take x or this y or this a plus b, if I take tan theta is tan inverse x is a, this tan cot inverse x is b, a plus b is less 0 is less than or equal to pi by 2. Okay, so in this way, or this minus pi by 2, if I add pi by 2 in both sides, it will be del pi. So 0 to pi, this we have taken here. A plus b, if I take tan theta is, or tan inverse x in this case, tan inverse x, this is cot inverse x. Both are a plus b. In this way, a plus b lying between 0 to pi by 2. In that also, then tan inverse x equals cot inverse x. Okay, it's belongs to 0 to pi by 2, because this is the first part in talking. Okay, the proving of this, the interval is defined in this way, and then in this interval, we have to take those points here. What are those points? That tan theta equal to cot of pi by 2 minus theta. Okay, then or then theta is tan inverse x here. Tan inverse x is theta, or theta equal to cot. This is tan theta equal to, here x equal to this tan theta, or tan theta is cot of pi by 2 minus theta. This is cot x equal to cot theta, or cot inverse x equal to pi by 2 minus theta. In this way, put the theta here value, theta plus cot inverse x equal to pi by 2. And then we substitute value of theta, which is we have taken tan inverse x. Here theta becomes 0 as cot inverse x, sorry, tan inverse x. Okay, so this is the only process with the help of which we can prove that yes, tan inverse x plus cot inverse x into pi by 2. So this is tan inverse x here, value of theta, and this is cot inverse x equal to pi by 2. So this is second degree part here. Similarly, the second part, or the third one, second inverse x and cosecant inverse x, that we have to define. The C part here, that is cosec inverse x plus secant inverse x equal to pi by 2. Okay, here x belongs to